All of the
trig identities.
all of the trig
Every
identities.
fundamental area of calculus.
Why would I want that on my fork?
Please let me I get that tattoo next to my body. It's not considered.
It's a conversation starter.
That's what I'm saying. Like, if I get that tattoo, like, it speaks something new.
It builds automatically.
There's actually rules on that. I don't know what they are, but you can't just.
It's like a little cheat sheet in my past.
Judah.
Might be
That would be automatic ethos.
All right. So first off, let me remind you that ACTM, if you are interested in signing up for that, I need your $5 before I can register you. There is a process of me getting the money to someone on campus, them making it a check, and then it getting to the university. So I only tell you that because if you give me the money after next week, I probably will not be able to get you in. It'll be out of my hands then. So if you're interested, make sure you give me the $5. All right, we've got one more handout today, which is number 89, which is a circuit. So I felt like a couple more practice questions trying to keep up with the difference between velocity, distance, displacement, and acceleration would be a good idea. So if you would, go ahead and look at question 1, see what you think. So in addition to this circuit today, I'm going to do the quick version of the 2 FRQs you guys had on the quizzes last time. Talk about what you needed to know and what the process was. And then I can go in depth on how to actually come up with the answers. But I felt like that might be helpful. And then I've got a list of stuff that I would prioritize in the order that I would prioritize them as far as preparing for your test. So one of the things you may want to get later today is your 5154 quiz back. Again, those are back there in your folder where you put them back yesterday. So as you finish your circuit, if you know that's one thing that would help you, then feel free to go and get that. Okay, but on our circuit, if we know velocity, how are we supposed to know initial velocity? What does that mean?
The starting position.
Okay, starting position or starting time. Initial just means at the beginning. So we want to know the velocity at time 0, initial velocity. So plug that in and what do you get? -8. Now on this one, I'm perfectly fine with you guys using a calculator on all of it. Integrating by hand, there's a couple derivatives by hand. That's fine if you want to practice it by hand, but really what I'm more focused on is you just trying to identify the differences that come up between these. So you will need a calculator on some of them anyway. Everybody okay with why that's -8? Okay, and let's look at box 2. And then I will get out of your way a little bit and let you move along and see what kind of hiccups you come up to. Okay, so how are you supposed to know if something's moving right, left, or not moving at all?
The sign of the velocity.
Okay, so if the velocity was,
Negative.
if velocity is negative, it's to the left. If velocity is positive is to the right? What about if it was stopped?
Equal to 0.
Okay, so how am I going to know at t equals 1? How do we know if it's going right, left, or stopped?
Plug one in T.
All right, just plug it in. You get 1 cubed. Again, you can use a calculator, I guess, but it's going to be more work to use a calculator here. That'd be 2 squared would be 4. So you ended up with -1. So what does that mean, Ben? Right or left? Because of this, it's going to the left. Okay, and then you need to know this to know what box 3 is. So they will build up a little bit where they'll take a little bit more effort than the first two, but work with that, and then I'll come around, so call me over as you get stuck and need a hand.
I think when you're done with this class, you're gonna be doing any math.
Yes.
When you go to Walmart, you like get out a calculator and start adding up how much everything.
Yes, absolutely I do.
Sometimes.
You think I keep track of that in my head?
If you're dude. Sometimes you gotta buy a lot of food.
Sometimes you're wrong.
Yeah, hey, what if you look for the derivative of how much food you bought this time?
Oh, that's easy.
Derivative of the constant is 0. Okay.
That's so
Harris, that's the most profound thought you've had all year.
So proud.
Oh, I was just writing stuff up right there. I was just, no.
We could use a calculator on this.
I assume so.
I just gotta get through this.
That would make sense.
It's so much harder.
Yeah.
It sounds like.
So what do we
You know,
use?
How'd you do it? 5, that's 5. How'd you do it? Okay. No. I'll throw it with them. Okay, I know it is. Well, like, how do you gonna do that? The balance here. Number 3.
Is that your fault?
No, you're taking back.
7.
Shouldn't that be 3? Didn't calculate. Second window, it's 100. No, that's just 2. Second. 8, 2, plus 3.
Okay, so that's like when you do that.
1 plus 1, this is what I did.
Is the whole thing gonna have to do with this?
You get 2 minutes, 5.25, right?
Minus 1.
Oh, you took, oh, yeah. Yep. Yeah, you,
Plus 1 squared.
I'm so used to. No.
boys.
It's 14.25.
What?
Yep. That would be.
One in doubt.
Oh, yeah. This one looks really good.
I just started it.
I would never talk to you.
You know, I wish I could have done time and dirty. I feel like you did time and dirty. How fun is it? Did you have the time and dirty? You know exactly.
Okay.
Build a bar, goes down. I never did.
I never did.
I thought TV show.
Oh, shit. And it's like 3 meals. That is really good.
3 weeks.
I wanna do that.
Why don't you just bring a motorcycle? Why don't you just like lay the track?
The mag
Like
is
one of those like.
Iowa points on one too.
Mango.
Friction.
Mango.
Is that limited?
Yeah, it's not that new. Like, it kind of sounds
Iowa 2.
I remember hearing about it.
No,
There's no way that worked.
Zero. So, like, between Iowa 2
4 points on one.
for cosine.
Oh, but it's
And then it's also
For
negative
number,
Oh, so you got like 4 into the
I'm a number 6.
2 Iowa 2 is positive.
What the heck?
Oh, shoot. I was on, I don't know, I brain jumped there.
Yeah, it's fine, it's fine. 4
Yeah.
points on one.
Because this is your goal. And this is your position. But you started at negative 8. So it's basically negative.
Oh, but it's.
Why did you just say that?
Did you already go see that?
I would have thought this
It's
was
not
easy.
C. You're a minus C type of guy, aren't you?
Thank you.
Same, right? Is it,
But we also have to check this one part.
what did I say, 4.1?
Um,
2, 7,
712.
7, 6.
Ah, I see what I did. Tis a pity.
But you also got to check this.
How do you, find
Oh wait, the actual moves positive.
how do you, prove that, like, how do you say,
The club doing all.
like, how do you write the proof if you got it using graphing?
Well, it's not really a proof, but you could justify. First off, your graph looks way
You find
different.
a zero.
Oh, I just submit.
Also find
Okay.
But there aren't any zeros. Oh, there are.
Yeah, from 0 to 6.
Okay. Well, how do you, you're saying it compared to here, what about the graph that makes you think that's part of your answer?
Oh, because velocity is positive.
Okay.
Oh,
Because velocity is greater than 0.
Velocity.
Velocity is positive. But here's the thing, and what I like about this question, one is you should change the window settings to 0 to 6 or whatever like you did, so it looks like this. Because 2, that's not one of your answers, that's not the answer.
my phone.
Okay, so it's negative 9 plus the integral.
You know he's got some of those.
Zero.
Trying to teach you a lesson. It's hard to see, but
Oh.
that's what the x-axis do. It's just so close. So if you change this, look, if you change this to a decimal, it'll be that. But you need to see that it's also above pi. So just because quick lines looks like it's not above, you need to be a little more.
It's like from pi over 2.
I got 3 over 1.
It's right here.
So can you go back up and just edit your own? Why didn't you just like this?
I decided to just redo.
Because it's a range, it's not a number.
They should like let you just go back up and edit.
Right, that's fine.
Oh, you allowed that?
Alright,
What did you do?
That's just what I put in.
yeah, it's actually.
Oh, we're over there?
Alpha window.
No, we got-
Where is it? Unfair.
Because acceleration.
You gotta graph it.
Yeah, it is.
And then do
And then you do all that, and then your
Then you have to find all your
But you can find some roads.
You've got to find the that and then
No, but that's also my balance.
oh, you said it's 0 to 6. Okay. Oh, okay. You just gotta find that one. Okay, so
I think you might have done this on the first page too.
As soon as I turned it in, I was like,
Down here, I think you just did the arithmetic just a little bit off. That's kind of a lot cleaner than that. That makes it.
Yeah, I think it like.
You did not.
So I assume this is
Yeah, I guess
that.
we're just a little.
I didn't know this
because
was.
it's been 10 minutes, 20 minutes.
Like that. I would too.
Oh.
What is that?
Let's see, negative. Oh, this is supposed to be.
I emailed this to you the other day, but.
Oh,
there's a
yeah,
hard
thank you
copy.
for that.
So, are we doing
I need your help on that.
And then that's all.
I got stuck and all this other stuff in, so.
I have the antiderivative.
This is how far it is. Total distance.
I think that
I need to integrate you, but what are my nouns?
Yeah.
Okay, what's her graph?
What is it equal?
Negative 1.157.
Oh, you forgot to multiply.
I forgot to add 1 to get a half. Get a.
So this
Wait,
is,
that's.
Two,
yeah.
the 1 halfway.
Wait a minute, that's just.
Okay, here, look. What you do, so, first you have that now, so you got to that point, right?
Right. They're supposed to be.
And you take the integral power by 1 to 1/2, and then you divide by the power. So 1 divided by 1/2 is 2, so 2 goes right there. So then it's now 1/4 times 2 to 1/2. But you have to, you factor in the balance just in this part. You don't mess with the 1/4 until the very end.
Displacement.
Yes.
Yeah, it's on the back. What is the number?
I grabbed it.
9.
Oh, but like.
It's already over your head.
Do you like do?
I'm gonna
plug
check
in?
Well,
Like I grabbed it, but I just.
Well,
What is that? Like.
why don't you, if you count this decimal, right? Calculate the decimal.
Okay.
And then compare it.
Oh, yeah, sport calculator like you, man.
And then it like has, I know it has some six stuff.
This is the 3 pi over
I'm thinking of the
6.
first part.
And what I like about this question,
Yeah.
this
I
is
think that
above the
might be where it,
x-axis
like,
too,
touches the
it's just your
ground.
social
Yeah,
balance part.
but yeah.
So you need to.
Doesn't like it's I don't know if there's like
Why
another way
not?
to do it.
Yeah.
I'm sure. It just feel like I don't know.
That's what I'm saying, it's hard to know this, but it's.
You're the pounder.
Best guess. Thank you. Let me know when you get to 9. You and whoever gets it. Where'd you go?
I'm there.
You're at 9?
Yep.
What'd you get?
So you need to take
2 integrals.
The integral of an
You gonna help me with 9? How's that, Michael?
One of those, like 0 on top 6.
I think you said the derivative.
I've set my own bounds, that might be the problem.
No, you're taking the derivative. Oh, moving to the right. You
I
took the
know.
derivative.
No, you're not.
You took
It's
the
not
derivative.
You have to integrate.
Yeah, you integrate
What were your
that.
Acceleration equals 0 since it's asking for
But it
Start,
says, but it
it
says after
starts
4 seconds.
Because it's speed
after,
control.
like after 4 seconds, so it goes to 4. And
Oh
it's
wait, no,
supposed to-
you do step velocity.
After 4 seconds, and like, after 2 seconds, how far have you traveled? So you travel for 2 seconds.
Oh, see, I just read that wrong, that's fine. Never mind, that's not.
Wait, what'd you get?
9.3 sounds right.
That's it.
That's acceleration, so-
Oh my gosh.
Oh, yeah. Turn the machine
Wait.
I know some of you are starting to get there, but I think the hardest one is question 10. So don't give up on it, but it's probably one we'll talk about on the board.
Oh, yeah, we did it.
Just integrating a bunch. Takes a little bit of us, right?
I wanna do that.
You said it was weird.
Hey,
Remember your equations.
wait, I didn't really want to get to it.
But
You know?
you're gonna have to find the answer to the question.
Okay, so you know what I can help on.
Oh.
How do you get there?
Okay, so you click the.
Oh, right, there we go. So that would be,
You have like cosine of 0 is just
and then that equals 0. I got this one back there.
No, yeah, cause you have the pounds.
Yeah. I just know that.
That's not the final answer, that's just part of it.
What balance are you?
Sorry, I'll try.
Wait a minute, you look it down. Did you put that sign forward to the sign?
That's the big problem.
That's really not helpful, actually.
Not really.
That's how you do it.
I'm gonna wait to help you out.
In fact, if you do get stuck on 10, you might just do the last 2 questions and then come back to it.
I'm gonna try to find out.
Because you know that velocity is 0 is 0 symmetrical. Because when it starts, you should put 0 in and then you gotta see.
Oh wait. I think not just in order to get around 5 pounds and plug the new input into the pocket. I think that's
You can take it twice.
the indefinite.
Sorry, what did you say?
Get the answer.
She's not explaining to me, 1.8.
That's.
But you want to do
I'm gonna do that.
So you don't like X plus 2 is 2.
the acceleration.
Then you
Oh wait, we have to put in the bound.
How do you? You have to integrate.
The Band-Aid,
Oh, you're integrating.
a while ago, I got.
Yeah.
I actually did,
I don't know what it
I'm not
is.
perfect.
I don't know.
You don't really remember the situation.
Yeah, no, I think it's still in like Favorite Police Department. No, but when they suture, the scar tissue develops, there's
We
a
need to
cold
like
bump.
integrate it by hand.
So you know who Nelly is? Nelly?
Nelly has a golf club.
It was like 2000s rapper. And he
Oh,
used to
yeah.
always wear a Band-Aid. It was like this. Yeah, like that was just part of
It could be you, like a.
No, it's you're the one with the Band-Aid on.
Yes.
I think it has to be, that's the answer.
So you go down to
Because,
Okay,
wait,
so
no,
we
it's
have.
I guess that's the
It's really.
baller.
Oh, because if you integrate it.
Which I actually tend to not do a lot. For example,
Chill there.
mine is whatever.
Keep going.
You're raising.
Okay, yeah, but you're not.
Oh, that's your take.
Yeah, it's 16.5.
Yeah,
So it's probably about
6 said that a particle moves along the x-axis.
That means
And
Zero.
Then you say just take that for the calculation. So what you just went
How
through
far
is
travel is this place?
Order what
That's
it is.
velocity.
I'm just gonna start where
Solid
you want to take it.
Okay, yeah, so now you gotta find distance.
So why don't we just grab it?
No, that is, but now since you can put it in bounds. Since you
Velocity
can-
positive.
Yes.
It's not gonna
Change your window setting.
Oh, that's
Is
not
that,
right.
wait, is that it?
Yeah.
Is it like a cube? Yeah.
How do you find plus, how do you find?
I don't think you need a plus C because you just don't take it into account. And it starts from rest, it says, so,
Oh, you're right.
yeah. So it's just gonna be zero. Or whatever it's plus C is gonna make it zero. I think. Yeah, it's gonna be zero, that's zero. Then you just integrate.
Well, I know it's at least gonna equal 0.
So if you
Maybe mine just range.
Yeah,
oh, when it's unbounded.
yeah, from zero to
you
four,
have to-
and then
If it has, because if it has bounded, it's solid.
You got something like that?
Then you don't. That's what you do. The bottom, the top class.
On the right track. That graph is good.
Is that one?
16.533. That was the, how far down.
Define your C. Graph.
Because you want, I know that's not what I, that's what I said.
Sometimes you just have to do some things by hand.
I thought it was one velocity acceleration, like 6.
Learn the hard way, and that's
I think it's like down. I had to remove 5.
I used to be 40. No. Do it. So you have that,
So you integrate this, right? And so for plus C, and then find the X.
C plus 0, so that means you should, you know, there's a same variable. But it'd be zero, so
Minus 19 t
equals 6, so that means that you plus 0 plus X.
equals 6 minus t is
So C equals 6.
Yes. So this is plus 6. Now you need to put it in your calculator. Then, then or wait. No. You don't have
Zero.
your, this, you wanna grab it. Okay.
So,
So, my calculator is acting. Put a picture in there.
because you put down D, you put down X. Try putting an X.
Oh, maybe that's it. I'll get you.
But you need like.
Gosh,
Must have this. Then you grab, I mean, you can probably just take it now.
Oh, yeah,
So
on this question, you find that's the x-axis and those are the bounds. On this question, is it the same thing? Or is this with
Or y equals 0 is the x-axis.
Okay, so it's just a different way of
Yeah,
saying it.
different way to say the same thing.
the x-axis equals
Let's go across some,
yeah, you're right.
And then after that, it's not total, but until 3 pi over 2.
It's also a quadratic, so it must be, you know.
She was like, you just
goes up to
like,
6.
yeah, I can.
You could also.
Oh, it has 2 points.
How,
Probably it's close.
They put like a bag of my house.
Are you just
And then also like
not really, but like kind of saw
I know, it's like
that if you plug in pi over 2,
ratcheting my head.
cosine pi over 2 is 0. Same with 3 pi over 2. So immediately make the equation 0. Same like if you add it to 0, there's circle.
Yeah, we got sales.
So then you know where to go from there.
Zoom.
Probably because we answered for me.
I mean, from 0 to 0.
I did that too.
Then I guess.
Absolutely, this one. That's better than.
Does that have graphs?
Yes.
Am I just finding the zeros of it?
I did it.
Probably one you said.
10 or?
Yes.
6.
Really?
Yep, 6 days.
You have the graphics?
I did graphic, but I couldn't really see that.
Yeah. But
I
when
can
you look
see
at your
that.
choices.
Well, yeah, I know.
Yeah.
Okay, a couple more minutes, and I'm gonna look at question box 10 here, since I told you I would, just because I think that's the hardest one. But those of you that got it and are finished, remember that you can move on to look over your test review. You're welcome to go get your 5154 quiz if you want to look at that some more. But there's several different things you could be looking at.
The total distance of elements is just different to
See if no one gets it out.
Oh, yeah, I forgot to put the. I forgot to put the.
9.022.
No, I mean, that makes sense because it's the last question.
Is this number 89? No.
Yes. Okay, so question 10. It's this box. If you haven't made it there yet, you might want to jump ahead to it, since this will be your chance for me to go over it with you. But the only thing that makes this one just a touch harder is that there is two layers of integration here. They give you acceleration. Guys, I need y'all to hold off, please. Acceleration. So if you integrate that, it would give you the function before it, which would be velocity. But what makes this question a little bit harder is that your answer doesn't come from something about the velocity, it comes from the position. So you have to integrate a second time. So what I did was, for consistency here, I said my velocity, well, it starts off at rest, so that means the velocity is 0, plus how it changes over time. So integrating acceleration gives you velocity. Now, I think one of the traps that you can fall into is it's tempting to say 0 to 4 here. But if we do that, we're going to get a number. We need to do more work with that. So I want to keep it a little bit more generic here. So, because this is a variable, your calculator is not going to help you out. In fact, you can put a t in there, but whatever number you have stored in for t is what it's going to evaluate it. So it's going to give you some number that's probably not what you want. So I went ahead and integrated by hand. I did the power rule, undid the power rule, and then evaluated from 0 to t. So plugging in t makes all of that stuff stay t. Plugging in 0 makes it all go 0, subtract them. So that's what I got for velocity. But it wants to know position. How far does it travel in 4 seconds? So I want to know how velocity changed from t equals 0 to t equals 4. Now I want to use numbers because I want a numerical answer in the end. And then I just let my calculator do that. But a little bit longer because you had to integrate twice. Once to go from acceleration to velocity, and then a second time to go from velocity to position. Now, you don't need just you don't need this for this class, but just so you guys know, if you like looked in the back of your textbook at some stuff or sometime in like Cal 3, you are going to see questions that look like this. And what do you think that means to do? Yeah, you're just going to integrate it and then integrate it again. So that'll be in your future if you stick with calculus, which is kind of what we did here. Okay, I'd also like to take a few minutes here to talk about the stuff that you needed to know and the process to getting all 9 points on the last FRQs from the quiz. So let me speak on that for a few minutes. And again, this will just be very brief, but then I'll give you a chance to ask about where some of the numbers came from. So one of the FRQs that you guys had last time, and of course your Chapter 5 FRQ is not going to be exactly the same, but it could have some of the same pieces to it. But one of them was about some snow. There was a function that added snow. There was a function that, there was snow that was melted, M, snow that was added, S, I don't remember why it was S, and then it had a starting amount. You had 40 inches of snow. And question A wanted to know how much snow melts over the 6 hours. So to know how much snow melts over 6 hours, you needed to integrate the melting function from 0 to 6. The most common mistake here is to just plug 6 into that, but that would tell you how much snow is melting at the instant 6 hours, not how much is melted from time 0 to 6. So this was a calculator one, so all you had to do was type that in, and the answer should be 2 inches. I'm going to go ahead and put out the answers here, because if you look at your quiz later and you miss that question and you're not sure if you really understand it or not, you could rework it and make sure that you get the same answer we're supposed to. So that's all there was to part A. How much snow melts over 6 hours? Integrate 0 to 6 as the melting function. Part B wanted a function that represents how much snow you have for any given time. So you've got how much you started with. To me, this is just like one of the questions on your circuit and one of the multiple choice questions. But you've got how much you started with plus how it changes. And how it changes comes from integration. Integrate, add how much it's adding, and subtract how much it is subtracting. You're starting off at time 0. And once again, the most common mistake is that people want to put a 6 here. But this is going to add how much snow is added over 6 hours and subtract how much snow is subtracted over 6 hours. That may not be what I want to know. If I want to know how much snow there is at 4 hours, I don't want it to go all the way up to 6. I want it to go to the value that I want to know how much snow there is. So you need to keep that a variable so that it can change to whatever you need this to be. So initial amount plus how it changes. Integration keeps up with how it changes. This one's being added because that's the snow that's being added. This one's being subtracted because that's the snow that's melting. Okay, part C said something about find when, what was the wording? The rate of change of the snow is 0. So instantaneous rate of change is derivative. So they were really asking you, when does the derivative of your function in part B equal 0? So you had to take the derivative. The derivative of 40 would be 0. The derivative of this is the second fundamental theorem of calculus. The derivative of this is the second fundamental theorem of calculus again. And if you want to know where this equals 0, I just added one of these over, and you could either finish that with graphing or with equation solver. Okay, and then the last part before I let you ask some more detailed questions, this is the answer that you should get if you need to rework it. The last part had 3 points, and it wanted you to find out when and how much was the max amount of snow. So as soon as I hear the word max or min, if I want to know the absolute max amount of snow or the absolute min amount of snow, I'm thinking extreme value theorem. Test the endpoints and test any critical numbers. So you had to find the critical numbers, and I used my calculator to do that, but the critical number was at 4.241. They gave 1 point if you found the critical number, said anything about it. They gave 1 point if you found these values correctly. So you could plug 0 into this and solve, although they gave you this one to start off with. You had to plug 6 into this, and then you had to plug in the critical number into this, and these two were close. Oh, I wrote these backwards, sorry. These two were very close, but 95% of the time, if it wants you to find a absolute max or absolute min, it's probably a critical number and not an endpoint.
Wait, how'd you get 4.241?
That's the critical number. I just used my calculator to do it, but we can go over that specifically if we need to. So there was 1 point if you showed all of those values, and then the final 9th point came from stating, here's the max amount of snow, and here's when it occurs. Okay, so anybody have anything to ask about part A? Part B? Part B got used for C and D, so it was kind of important. Yeah.
If you got like part B incorrect, and you used the formulas correctly for C and D, would you have gotten any points there?
Yes. The one exception I think I've read before is like if you just put something like totally just made up or something, then sometimes they don't. But like if you pick something that was just like, you know, really easy, like the number of snow or the amount of snow is always 40. So then it's like at times 0 is 40, at times 6 is 40. Like they're not gonna excuse this part. You know what I mean? So, but in theory, yes. If you just had like, I don't know, if you accidentally did 30 here, but then the rest of your work was consistent, you would lose this point, but not those points.
Okay.
Okay, what about part C? How I knew what the derivative was, or how I found out where it equaled 0. Okay, in part D, critical number, how I evaluated those to get those 3 numbers, or how I knew when the most amount of snow came and how much it was.
Hey, could you show me what you did to find the 4.24?
Yeah, let's see. So critical numbers are when the first derivative is 0 or undefined. So I believe right here is where I took the derivative. So I think I graphed this. I graphed the function for snow minus the function for it being melted. And then I wanted to figure out where it equaled 0, so I just had my calculator graph it and found the x-intercept. All right, and then the other one, again, quick version first, and then I give you a chance to speak up before I move on. But in the other FRQ, it gave a velocity function, and part A asked about when is the speed 2. Well, if the speed is 2, what does that mean velocity could be? Okay, or positive or negative 2, right? Speed is the absolute value of that. So if you even just said that, if you showed some connection that you knew that if speed is 2, velocity could be positive 2 or negative 2, then you get 1 point. The other part of this question is asking when that happens. So what I did is I graphed the velocity function, I graphed y equals 2, and I graphed y equals negative 2, and I found those points of intersection, and I did all of that on my calculator. One of these times came from when velocity was negative 2, and one came from when it was positive 2. But the key is, I mean, the main, like, it's not like these numbers are important because the numbers are going to be different the next time, but you have to know how speed relates to velocity to be able to do something like that. That's all you needed for A. B is similar to the one we did in B on the other one and also on your circuit. It wants you to come up with a position equation, and it had 2 parts. What would the position be at time equals 5? So if you have velocity and you want position, you should integrate. But they also told us in the question you start off at 10. So you've got your starting amount plus how it changes. What would my bounds be here though? Because I want this to work for any time. It's got to be 0 to t. If you put a number here, this is only calculating how it's changed up into that moment. If you want it to be dynamic, you need it to be that. And then S of 5, you just plug 5 into that, and that's where this number came from.
Wait, what equation did you plug 2 and negative 2 into to get 3.4? So
The velocity equation that was given to you. I'm just not writing it out, but you can look at this in a minute when I'm done. Well, actually, it doesn't show because I did it in my calculator, but I just graphed the velocity function. I graphed y equals 2 and y equals negative 2, and then I looked for the points of intersection. Okay, C, find all the times between 0 and 5 in which the particle changes direction. That also sounds like something you guys did on the circuit today. If something's going to change direction, here's the biggest mistake that happened on this. Not when velocity is 0. Or not only, I should say. The problem with this is, here, let's pretend like this is a velocity graph. If my velocity is 0 right here, does that mean it's changing directions at that time? It does if it changes from positive to negative or negative to positive, but what if it touches and then doesn't go that way? Does that make sense? Velocity has to change direction. Velocity has to go from being positive to negative or negative to positive. And so, I don't know, just like your circuit question, I don't know, one of the first couple there, I graphed it, and that happened 2 times. At 3.318 and 0.53. One of them had this reasoning and one had that reasoning. But it's not just when velocity is 0, it's when velocity is changing signs. Okay, and then the last part of this one is the speed of the particle increasing or decreasing at time t equals 4. So, to know if something's speeding up or slowing down, you need to look at the signs. So you needed to plug 4 into velocity, see if it was positive or negative. You needed to find the acceleration at time 4, and there was a handful of people that took the velocity function and did the derivative to get this, and that's fine, I guess, if you want to do it, but it was calculator. Calculator can do a derivative for you if you wanted a specific value. So I just asked it to take the derivative at time equals 4, and when they're both negative, it's speeding up to the left, or if they were both positive, it was speeding up to the right. On this FRQ, B of 4 and A of 4 were both negative, so it was speeding up. So you just need to say it was speeding up for one point, and because velocity and acceleration were both negative, or because they had to both had the same sign. Okay, so that was the final part of that one. So part A, knowing how speed and velocity interact. We're okay with that now?
What did you mean you found the point where they intersected?
So the velocity function, look like this. Okay, so if you graph this, if you just graph the velocity function, can you see where it is equal to 2 and negative 2? Well, actually, this question said you only care about 0 to 5, so let me change that. So here is velocity. Can you see when velocity is 2 or negative 2? Well, if you graph 2 as its own line, now I can see where velocity is 2. If I also graph negative 2, now I can see where it's 2 and negative 2. And if you do the second trace, instead of picking 0, yeah, or you can do trace, but you got to get it within 3. So first curve, second curve, guess, takes you to the intersection. Velocity was 2 at, I must not have typed the function in right, because that's not the right number, but that's the process. Yes.
How do you do the intersect function again?
Second trace, the same way that you do the find the 0 or find the max, just pick intersect instead. And it will, since you could have multiple curves on your graph, it's going to ask for one of the curves first. So like I'm picking blue, which is velocity, and then hit enter, and then it's going to ask for your second curve. So if I hit enter here, it's going to find the intersection of these two, which is going to be right there.
Okay.
Enter to skip guess. And if you want to find this one, you do the same steps. Here's my first curve. Now I don't want to hit enter here. I don't want this to be my second curve. I have to go down and say here's my second curve.
Okay, cool.
And it can do that. So it's almost the same steps as tracing a 0. You don't have to do it that way, by the way. You could also have done equation solver. It's just that you would have to do it twice, just a different option. So. Okay, so part B, this was consistent in both of these, and we've seen this a lot. So any questions about that? Part C, why it's changing directions if velocity switches from positive to negative or negative to positive, or how I did it in my calculator. Okay, or part D, how I knew it was speeding up instead of slowing down, and how did I know velocity was negative and acceleration was negative. Any questions about that part? Okay, so I'm going to come around and help out some more here, but at this point we probably are in quite a few different places. So I'd like you to finish up the circuit first. Like I did for you on your last test, I prioritized the resources that I think are the most important in the order that I would check them off your to-do list. So first off, there's several U substitution questions on your test. It's at least 3 and maybe as much as 6. There's several. So I feel like you've done a lot of U substitution practice for me already, but I'll just be honest, this is one of the skills that some people just need more practice on. One of your AMI days, I added a few resources to the website. So there's one worksheet that lets you practice just picking out U and what it would kind of look like. So if you're having trouble starting U substitution, you might utilize that. And then there's a big worksheet front and back that must have like 50, 60 questions. I think Ms. Cross makes her class do that instead of the book work, but that would be a good one to get extra practice with as well, because there is also solutions there. So if you think, or if you are unsure if you're solid on U substitution, that would be the first thing I would put more effort into. The second thing I would make sure that I checked off would be the Chapter 5 review. So it's only one page, but there's 3 FRQs on the front, some practice questions on the back. I would make sure I was solid about that next. Also, last period, open that up in Google Classroom. So those of you that are finished with it and want to turn it in, so you don't run the risk of losing it or something, you are welcome to do that. Otherwise, I will ask for it completed before we start the test Tuesday. The third most important thing, I think, is the mistakes that you may have made on the 5154 quiz. So again, you're welcome to go back and get that today, but those same type of questions are still from Chapter 5, so they have a fair chance of being on your Chapter 5 test. I would make sure that I felt good with those. And then by far the least important here would be that handout we did last time over logarithmic integration, but it might help to look at it for a couple minutes, just in case. But that's the resources. If I was you, I would look at, and the order that I would check them off your to-do list. So, yeah, that's on the agenda page, so you guys can pull that up later on as you need to. But once you're done with the circuit, if you don't think you need to use substitution practice, if you've not finished the review, you could do that. If you need to study the review, do that. If you think you might need to look at the quiz again, do that. If you've done all of that, take a few minutes, look at that 88 last time. But that's the order I would do. Spend the rest of your class on.
Okay, so I just ended up integrating it by hand because I heard the integral calculator on so I always
No, I wanted to do it, but I didn't. And now I have to do it right now.
The problem is if I make a minor, it's like, there's not enough to be able to try. And it doesn't make
now
very
we
much.
Oh wait, no, I did that.
No, we
Because you have to put in the but that's the same with the
So you just can't. You're always welcome to ask.
No.
I'm curious about your 11.
No.
Doing a lot of where I was at.
46, but that's not good.
No, you just put it as an indefinite integral. And lift up the
If you do get your quiz out of your folder today, please make sure you put it back in there before you go. And if you decide you want to look at it more, remember any advisory is fine once they're made up, which is the case now. So even Tuesday, you can come in and look at it again if you needed to. The other thing, when we came back from winter break, I warned you guys here at the start of this semester was kind of tough just because of all the information that there is. And I mean, that's just the way it works, but just for some perspectives here, the stuff that we've been doing since you have come back from winter break makes up 17 to 20% of the AP exam. So it is a lot, but I mean, that's potentially a fifth of what this stuff is potentially a fifth of what they expect you to know on the AP exam. So that goes a long way for being ready on that. Okay, please call me over and let me help on whatever it is you're looking at.
The person who did this, you see how this amount of area on the right is equal to this amount of area on the left? So they just chose to integrate from 0 to 2 and then they double it. I would just integrate from -2 and not double it.
I just did this because
It's not the critical numbers, it's just like where those two things intersect. It's usually graph this and this, or the equation be together. That's how you find it.
So I'm finding where this
Is that the one you just showed me?
no, that one the speeding up.
Might as well get all of them. That's why I was waiting to see how long you're still moving them.
Pero are you done with the review?
No, I think that might be it. No.
What?
Are you done with the review?
No.
Okay.
You must never be here. Dave has my papers. I was wondering. That one's old. That's the oldest one. Yeah. 27. Wow. Look at that power one. Gosh. Yeah, I agree. It's a lifetime ago. Yeah.
Let's wait until you're just moving those papers.
I got this little, I got this thing to read with.
Got it.
It's good. Like you put it close to.
Yes.
Or you put it close to.
Through the first.
Yep.
Where can you find
It's back here in the folder. You got just put yours away for you. So one of those that previous AP Calc. Just find the folder with your name in it, and it'll be in there.
Why'd you put it close?
Well, I saw it after you, I think that.
That's after you take the integral. You just and then.
This is velocity.
Yeah.
This the
Yeah, you take it's the
acceleration.
You take the integral back to the value of velocity. So why would you?
Some years I do. It's just.
You just put in cosine sub sine.
It's low on my priority list. Because if I'm doing
And then
that,
minus 2 cosine, because that would be the integral to
or if I
sine.
take it up, like I don't want to take it up and then not have the test.
How was that? Maybe you were supposed or maybe it was
Oh, wow. Yeah. But there is a balance though, because they won't make you do insanely hard stuff like that. So.
Yeah, it's also, I think it's just good practice for like FAQs and stuff.
Okay. Yeah, I'm not discouraging you. I'm just making sure. How's it going?
pretty good. I think
Got all the FRQs on the review. Yeah, you can take it back to your desk.
yeah, I was just.
They got a lot of parts to them.
So it says bound by the axis. So it means the area of what was called. Basically not infinite area, basically, right?
If you grab this, it's gonna look like this,
Okay.
and then the x-axis, so you're trying to find this area here.
Okay, so do we do it by finding where the zeros are and then graph the area between?
From there to, integrating from there to there.
Yeah.
The intersections.
Okay, I keep getting 2 pi or like 6.28 on this one. The answer is 9.82. But you put the integral, you put it as minus cosine t. You got the right answer. But that's like, but kept this as 1, so I'm like confused. Yeah. Perfect.
This stuff. I already know what how are you feeling about I don't think
Oh.
Mine is in radians. What was it? Nice. I mean, just went in. Yeah, but
You don't, you shouldn't keep it until that might do this stuff. You need to make sure it works without that.
oh, no, I just checked.
What does it mean bound by? What does it mean by
Yeah, you're right. Something just means like stuff that's traffic. So this is no different than the x-axis is like.
Those are some, just
Oh, right.
some next over some. Oh, yeah, I saw that. I didn't know. Is it a secant square root? Yeah, just have that. Must not be fast.
Is there something wrong with those? They're not my solutions.
Oh, no. I just think they're.
Dear God.
Oh, yeah, you gotta refresh it.
Am I really supposed to be able to do this without a calculator? I have to. This is why I fail. Can I do the calculus without a calculator? Yes. Once it starts getting here, that's it.
I would say that this mostly the arithmetic wouldn't show up on no calculator.
Okay.
At least
That's
not
all that
this time.
matters.
But things like getting a common denominator,
Yeah,
so you
yeah,
can
yeah.
subtract, like that could happen, but maybe that long and that much arithmetic, I would say would probably would show up.
Okay.
Most no calculator questions are more
What a
conceptual
coincidence.
than conversational like this.
No, I can do the calculus. I just didn't exactly know this.
We're going to so
I'm making it through.
to get my extra time swipe on my semen density, I reduce this. What's the
This is the second derivative. So if you want the first derivative, take it out.
yeah.
If you take the derivative of the second derivative, you're gonna get a third derivative. You're going the wrong direction. You need to integrate it, which is gonna give you a plus c. With this, you can solve for c. Then you're gonna have your first derivative.
Then I'm gonna
Then you can integrate it one more time.
function then I will use this one.
And slide for your second c.
He's pretty smart, but like, not enough to act like that. No.
I'm wondering how
He's,
Then you're curious.
I don't understand it.
Okay.
I'm not necessarily against it, but I just don't.
You're not against it?
Not necessarily.
I've been against it from the beginning.
I'm kind of against it, cause like,
So you can do that by hand.
I don't know if I want those two together.
I don't know how compatible.
They aren't. At all. I know both of them. No.
That's gonna end up being such a.
It's not, it won't work. It won't work. Carter, that is not the kind of person that they need to be with. That's not gonna be a successful relationship if it does happen. And I doubt it's going to be knowing
No, honestly.
Why is that? Why is that what they're going after?
How do you do that?
Because he's like that.
It doesn't make sense. I don't understand
Which is
it.
why undoing the power rule there doesn't make
so much
sense.
more time to erase
To integrate 1 over x, you shouldn't be trying to undo the power rule.
You're actually doing that.
That's the log rule. That's why we need the log rule.
If you want to say level,
You can't get around it.
I mean,
You put on a
you have this honesty too, but there's not one C.
It's just, I
So
feel so.
can't read. Too much time.
So I just, by lucky mistake, I put one there. Just by luck, I put one.
Oh, whatever.
Because if
Yeah.
displacement
I mean,
is,
that's part of it, multiple choice.
like if I walk.
Sometimes you're gonna get
so I walk
Yeah.
4
But
blocks.
sometimes you'll work it out, see an answer there, and you think it must be right, you see your answer,
Yeah.
and it's just, that's a good distractor, it's like it's a common mistake.
Putting that in absolute values, every single
Yeah.
increment on which works and
But
adds
I'll have
up
one nature
to
test,
that
there'll be some you don't know, and you make a good guess, and you're gonna.
You get it right.
Whereas no absolute value says you move
I
2
can.
miles.
Like if it's like a low file,
Uh,
low frequency, it's like, is it?
absolute value would say you move 6 times to.
Yeah.
Does that make sense? Yeah.
I like.
And then I looked at the first
So when you're finding this area, you're really like,
Yeah,
finding the puzzle.
that's true.
but the second, the first one should say
When you use this, when you find that here, you can basically, as you follow this line, the total value.
Yeah, and then you divide it by.
2/3.
Like days or days?
Not in one area.
Oh, but not like.
If you have two of these.
You actually.
I have one test that there's
You
like
divide it by
the exact
two.
same time. So I have to
So
make
if
them.
you integrate this from 0 to 2,
We're all
you're gonna get the
different, just
total
like-
value from 0 to 2.
The same one.
Yeah.
But then divided by 2.
So it's like makeup world.
I would choose those.
They don't do makeup for languages because they're so, like, when you, like, can do them.
Why is it 16?
I was just looking at the didn't list make sense, like I got two
What's 16? Like what's the decimal?
Yeah, but you get.
No, but where would it?
So I think that like was brown.
Okay.
I don't think there's five over.
4 in here. 4. 10 is 4 in here.
16.
So this is, so it looks like when you're integrated, you have 4/3.
Is that times 2/3?
Yeah. Yeah, you can divide that to X to that.
16/3? It's just 16/3. I gotta hold on. I gotta finish up right there.
Yeah, what's up?
You can't say.
I can.
You get a expansion.
Well, I'm trying to see plugging this in.
Oh, mirror. Come on, man. Don't try to down me in survey. Yeah, you still get something out of it. I used to use it for Really? Yeah.
So is your F prime next to 1/2 this 4?
No.
What's your F prime?
-1 over square root of X.
-1 over square root of X.
Square root of X. What are you doing in your head? What is that?
Just ponder. Hey, Junior, it's not nice. Something it's about.
Have you got the 10 yet?
No. 3 pi over 2 by 4 pi over 3.
Nestled in quadrant 3.
Oh, I took the integrals.
I have a question.
Is it quick?
Yes.
Gotta finish up there. Okay, what is it?
I just don't get why they didn't change the bounds. Like, why did they not change the bounds? Because I didn't. It's 15.
No, it's not easy to. Actually, no, hold on.
They didn't change. See how they, right here, they were talking about U. So if they wrote the bounds, they would need the bounds in terms of U.
Yes.
But the A substituted that stuff back in for X. So your bounds should be in terms of X. Just
I mean, yeah.
if you're integrating something U, some U stuff, DU, your bounds need to be in terms of U. If you're integrating something in terms of X, then you need your bounds to be in terms of X. I would not do it that way.
Okay. This isn't gonna be a short question anymore.
Okay, I'll come and help in a minute. Okay.
didn't really help much, but the integration part of it should come out to be exactly.
Okay. Let's calm down. What is it? You wanna erase that? What is it? I don't know.
I didn't use
No, erase it.
No,
Yeah,
let me
we
see it,
don't.
let me see it, let me see it.
It is like almost dramatic, like the way you have this written, it looks like you haven't integrated yet.
Maybe something.
And then Q on it, Q's key, raise it parallel one. And then divide by the new power. Oh, I know what it is. Right here, your boundary 0 to 2, because you're common term that when you rewrote it turn into you, you gotta switch your bounds. So that should be.
Who's next?
I'm trying to find, it says continuous functions. I'll give it 5, that'd be asking for the period. I guess why is it from 1 to 5 instead of 0 to 5?
Instead of what time?
0 to 5.
0 to 5 is going to tell you how it changes from time 0 to 0 to 5. What's the value of 0?
NFBC?
Right, but we know the value of 1, so we just need to know how does it change from 1 to 5.
What is that?
Does Coach 5 told
Value.
me the one on Wednesdays?
I guess so you would just assume that that's what are the bounds that it was.
So I'm only supposed to do 2.
That is the bound.
You know the value of 1.
Yeah.
You want to know how it changes from 1 to 5. So that's the integration.
So I'll do one
You got this value to start off too,
other day.
and then the integration will tell you how it changes
Okay, do the
over
one on
time.
Wednesday, because the one on Friday is way harder.
It's like if on day 1 you had $2, and then this is how it changes over time. You want to know how to do it change like 2, day 3, day 4, day 5, and then add it to the $2 you had to start off.
So I guess you're just not worried at all about the.
But you wouldn't have known the one, right?
Well, we don't care about anything from 0 to 1 is the problem. We don't know what happens at 0 and 1, and it has no bearing on whether that's going to be a 5 or a like if it's day 1, I don't need to know what you had yesterday. Like, it doesn't matter.
My turn? But I don't get what you're saying. Like you're saying in terms of X.
Yeah, so if it's X, you integrate from 1 to 3.
The man at the shop said my instrument is fixed. Salvation.
We have all-state audition tomorrow.
And my instrument broke
It
last
is
night.
terrifying.
Dude, I thought it was like non-stop practice. Listen, it's like, did I jump your first chair? If I didn't get anything, I'm gonna be so hyped.
Oh no, I don't.
It's still the same business.
I think it's like,
Bentonville.
no, I just, no, she's,
I just not gonna
no, I mean, I understand. I would be shocked if she got it. Respectfully, like,
It's just
it's like, he's at.
that was a different person. That person's curiosity. They always flip back and forth. I guess I'm like
Why do we ever change one?
Is that a seniority?
Your answer still has
Katrina's like secretary, or I could put her in our
two different things.
Oh my gosh. I did not go that far.
I've got this thing called calculator here. It's called calculator, but not prepared.
I had that accumulation.
Snow one? Yeah. Is that correct? That's 3 months.
Also, Colton.
Yeah.
Like, is that how I
Yeah.
When we did the notes, what I told you to do, because I never told you to
Why do you need to read
fix stuff that can't be read.
I did this myself.
I always just said, change it to you, change your bounds in terms of you, and not a problem.
All of Lovecraft works, and I'm very interested in the way that modern day cosmos horror is very different from how he established it as a notorious racist. But
I have no idea. I don't know what you're doing.
The instrument guy texted my mom and said that it was right.
I give you the roll.
This is the AT that we have. Can you pick this like part of it? Like,
Listen,
we have to play. Okay, I
as
think
long
my
as they
my
don't pick one
my
name.
instrument might be broken. I think, but I don't want to.
I just did all of
It's
it.
like the same thing, whatever U was equal to.
Sometimes I
that.
it doesn't.
If
Sometimes
you want like that
Yeah.
from that stuff.
Because sometimes I literally can't play the high notes.
And then
like,
switch
at
back to
all.
the
It could
X
be the
bound,
weather.
and if you wanna work that out, you'll get the same answer.
Sometimes I literally
So-
can't play it. But like with other high notes, fine. I don't understand how it's just that one.
Oh, there's no-
Oh, is high F the
Yeah, that's
highest? Is it at a E?
Exactly, I would say.
Yeah.
Or just like it requires a separate valve for the
Is this
high
right,
notes?
the SF3 minus MF3?
No, it's just
Yes.
a song key.
But unfortunately, this one guy only had one note there.
I can play
And it had to be,
correct one, and I rounded it correctly, and I put it in correct. Do you see anything in this that's,
Valid. Cause I'm working at tropical.
Did you get the same answer as me? Yeah.
Far walk. It's a long walk.
I can't look at it this. The scoring guide tell you what it was supposed to be.
Yeah.
Bye, Mr. Captain.
Bye.
Yeah.
Have a good weekend.
Or, I got it wrong. That's what I got. Or, 914.
Oh, I got.
Oh, I put, I switched up the, I switched up the 1 and the 9, and that's how I got the wrong answer.
Oh, seriously?
Yeah.
With the Mitchell thing, you just switched it up?
Yeah.
Oh, that's.
That's tough, man.
Oh, you found your problem.
You did good on it, though.
Yeah.
See, man, are you going to the gym today?
No, I haven't been in a while. The snow days kind of messed me up.
Yeah, I did that.
Snow days